guides. Will you recommend the Job Guide 360 interview guide to prospective job seekers?
Sure, I will. The guide is detailed and very comprehensive.
Okay, we have stacked up the sources today, and honestly, what they reveal is kind of the ultimate shortcut to modern iOS development mastery. We're not just talking basic concepts here. Our sources are really digging into the essential technical and strategic questions, the kind you hear in top-tier engineering interviews.
Yeah, and this deep dive, it really goes beyond just, interview prep.
Yeah.
It's more like a distillation of the most critical concepts, those strategic trade-offs you have to make to move past just coding features and into actually scaling high-quality apps.
Exactly. So our mission here is to pull out that core technical knowledge, the strategic thinking, and the collaborative skills you need, not just to build an app, but to ship it fast, keep it stable, and really own the whole process.
Right. We'll touch on everything from memory fundamentals all the way to handling a critical production fire.
Yeah.
It's quite a range.
It is. Okay, let's start unpacking this.
So when you're kicking off a big new feature, that first decision is always architecture, right?
Mm-hmm.
If the goal is speed, but also future testability,
Mm-hmm.
how do you set that structure up pragmatically?
Well,
the sources really lean towards MVVM, model view model, paired with a coordinator pattern for managing navigation flow.
okay, MVVM with a coordinator. That feels like the standard answer now, but what's the, immediate cost? Where do developers mess it up when they're trying to move fast?
That's a really good point. The immediate cost can be a bit more setup complexity. Where people often stumble is maybe putting business logic in the view by mistake, or the opposite, making view models way too fat, shoving service calls or navigation logic in there.
Right, keeping them clean is key.
Exactly. Keep those view models pure, easily testable, and lean towards Swift UI for the UI layer if your minimum OS target allows it.
And that interaction with, say, networking or storage, keeping that behind protocols, that's the safety net, isn't it?
Precisely. If your services are extracted behind protocols, swapping in mocks for tests is easy. You can even replace the whole networking stack later without a massive refactor. The advice is really, start small, ship a thin slice, maybe behind a feature flag, and only add structural complexity when the feature actually needs it. Don't over-engineer up front.
Makes sense. Okay, shifting from structure to stability. ARC. Automatic reference counting. Gotta master this. Memory leaks can be, deadly for an app. So what exactly is a retained cycle, mechanically speaking?
Think of it like two objects holding hands and refusing to let go when it's time to leave the party. They each have a strong reference to the other. ARC sees those strong references and thinks, oh, someone still needs this object, so it can't deallocate either of them.
They're stuck together forever.
Right, locked in a cycle, creating a persistent memory leak.
And how do we stop that permanent dance party from happening in our code?
It mostly comes down to being careful with capture lists and closures. Using weak or unowned captures is critical. And declaring delegates as weak. That breaks the strong circular reference path.
But just avoiding them isn't quite enough, right? You have to verify.
Absolutely mandatory.
Yeah.
Use instruments, specifically the leaks and allocations tools. And a good practical tip, add some simple logging in your DNet methods. It's a quick way to confirm objects are actually being released when you expect them to be.
Good one. Okay, let's talk concurrency. This feels like a huge source of modern bugs and instability if not handled right. When should you reach for async await versus, say, the older GCD or Combine?
Well, for any new code you're writing, the default should really be async await. It's just vastly more readable. Plus, it supports structured concurrency so well. Things like task and task group make error handling much more predictable.
So GCD is kind of legacy now, or still has a place?
It still has its place, but it's more niche. Reserve it for really lightweight dispatching fire and forget stuff, or when you absolutely have to integrate with older existing code that uses it.
Okay, and Combine, that's the powerful reactive framework. Where does it fit in this async await world?
Combine really shines when you're dealing with more complex streams of data, especially stuff that needs to update the UI reactively. Or when you're composing multiple asynchronous sources together, like reacting to user input and network changes at the same time.
But for simpler things.
Yeah, for a straightforward network call and then updating the UI, just stick with async await. Use the @mainActor attribute to make sure your UI updates happen on the right thread. It's generally the simplest and safest way forward for most common tasks.
Okay, so we've laid the groundwork for stability, careful memory management, structured concurrency. How do we build on that to handle, external chaos, starting with reliable networking?
Yeah, designing a solid networking layer needs a clear structure. The sources consistently point to three key pieces. First, a client protocol, probably wrapping URL session. Second, a dedicated request type. This encapsulates the path, HTTP method, any body data, and how to decode the response.
Encapsulation rate.
Yeah. And third, a really robust network error enum. Something specific and actionable, not just a generic error.
What's the secret sauce for reliability, though? It's not just making the call, it's surviving when things inevitably go wrong.
That's where the strategic bits come in. Reliability means thinking about retries. Implement exponential backoff, but only for idempotent requests, those you can safely repeat.
Like GT requests, usually?
Right. And critically, you need some kind of interceptor mechanism, something that can catch, say, a 401 unauthorized error, automatically refresh the auth token behind the scenes, and then retry the original request transparently.
Ah, the silent token refresh. That saves a lot of user frustration.
Huge amount. Okay, moving from network reliability to something the user feels immediately. Performance.
Yeah, that classic complaint, the feed scrolls really slowly. When you hear that, where's the absolute first place you look and what tool do you grab?
That is like the quintessential iOS performance benchmark, isn't it? The pain almost always comes from blocking the main thread. So I immediately reach for instruments, specifically the time profiler first. See exactly which functions are eating up time on the main thread during scrolling.
And allocation.
And allocations, yeah. Look for excessive repeated object creation. Are you creating new view models or formatting data on every single scroll event? That's a killer.
The sources mention some high-impact fixes for that scenario, things like image caching.
Absolutely. Caching decoded images is huge. Also, moving work off the main thread, things like complex calculations, data mapping, even some layout stuff if possible.
And simplifying the view hierarchy itself.
Definitely. Reducing the depth and complexity of your views helps rendering performance alive.
And the payoff can be massive, right? The sources quantified it.
Oh yeah, taking scroll performance from, say, a jerky 120 milliseconds per frame down to consistently under 16 milliseconds, that's the difference between unusable and buttery smooth 60 pp scrolling. It completely changes the perceived quality of the app.
Quality, yeah. Okay, resilience also means surviving when the network disappears. What's the recommended strategy for offline support and data persistence?
You generally need a layered approach here. Use the built-in URL cache for short-lived caching of network responses that handle simple cases well. But for your core domain models, the stuff the user really interacts with, you need a proper persistent store. Swift data or core data are the modern choices here.
Okay, cache for network stuff, persistent store for the important models, and when the user comes back online, syncing can be tricky.
Yeah, you need a clear strategy. The common approach is to queue up any writes made offline locally. Then, when connectivity returns, reconcile those changes with the server. The conflict resolution policy needs to be simple. Maybe just last write wins based on a server timestamp, or perhaps a field-level merge for specific data types.
Keep it simple if you can.
Right. And don't forget, background tasks are periodic syncing when the app isn't active. Crucially, make sure the UI clearly shows when data is stale or when the user is offline. Managing expectations is key.
Absolutely. Last piece in this section, user data protection and privacy. This is just non-negotiable. What are the baseline practices?
Security has to be baked in. At rest, sensitive stuff like API tokens or secrets must go in the keychain, not user defaults or somewhere insecure. For biometrics, Face ID, Touch ID use the secure enclave-backed credentials where possible. It provides hardware-level security.
And logging.
Never, ever log PII. Personally identifiable information. Just don't do it. It's too risky.
Right.
Beyond that, enforce App Transport Security, ATS, to ensure all network connections use secure TLS. And fundamentally, just practice data minimization. Collect only what you absolutely need.
Solid advice. Okay, let's shift gears slightly to process strategy and ship speed.
Right. In a fast-moving environment like a startup, you can't test everything. It's just not feasible. So what's the strategic way to approach testing when you're constrained?
It boils down to ruthless prioritization.
Yeah.
You absolutely have to focus your unit tests on the core business logic, your view models, your networking layer, the fragile critical parts.
Make up.
Then, for UI tests, be selective. Maybe just smoke tests for the top 5 or 10 critical user flows. And consider snapshot tests for visually complex custom views to catch rendering regressions easily.
And the enabler for all of this?
It comes back to architecture, really. Designing with dependency injection and using mocks from the very beginning makes everything testable. Without that, you're stuck.
Okay, so testing leads right into deployment. Setting up CI/CD, continuous integration, continuous deployment affordably, but also safely and quickly. What's the recommended tooling stack?
The sources consistently point towards using GitHub Actions combined with Fastlane.
Why that particular pair?
Well, Fastlane gives you really robust, scriptable automation for all the iOS-specific tasks, building, signing, testing, distributing to TestFlight or the App Store. And GitHub Actions provides relatively inexpensive, flexible runners to actually execute those Fastlane scripts automatically on every commit or pull request. They work really well together.
Gotcha. And the key factors for making that CI/CD pipeline fast. Because slow builds kill productivity.
Absolutely. Speed comes down to a few things. Caching dependencies aggressively between runs is huge things like CocoaPods or Swift Package Manager dependencies. Using parallel test runners can dramatically cut down your testing time.
Right.
And automating everything around the build, generating release notes, uploading debug symbols for crash reporting, minimize all that manual drudgery and potential for error.
Makes sense. Let's revisit frameworks for a second. Swift UI versus UIKit. We talked about using Swift UI for new screens, but how do you make that decision pragmatically day to day?
It's really a balancing act. Maturity versus speed, like you said. Use Swift UI for new, fairly self-contained screens. You'll generally build faster and get great consistency with less effort.
But for really complex custom layouts or areas where you need absolute stability and access to mature APIs.
That's where UIKit still often makes sense. Its maturity is undeniable, but the key is you don't have to choose one exclusively.
You can mix and match.
Exactly. Mix them safely. Use UI Hosting Controller to embed Swift UI views within your UIKit view controllers, and use UI View Representable or UI View Controller Representable to bring UIKit components into your Swift UI views. Pragmatism wins.
Okay, and the perennial challenge.
Yeah.
Technical debt.
Yeah.
How do you balance the pressure to ship features now with keeping the code base healthy long term?
You need a framework for it. The Boy Scout rule is a good starting point. Always leave the code a little cleaner than you found it. If you're touching an area, do a small, safe refactor while you're there.
A little bit by little bit.
Right. Timebox quick, safe debt fixes within your current sprint or development cycle. Don't let the small stuff fester.
And the bigger items.
Yeah.
The stuff that needs a real refactor.
Track those explicitly in the backlog. But, and this is important too, prioritize them based on their actual impact. Is this debt slowing down feature delivery? Is it causing bugs?
Quantify it.
Yes. Only reserve dedicated time for a major refactor when you can clearly show that the debt is actively hurting velocity or stability. It has to earn its place on the roadmap.
That makes sense. Okay, final segment. The developer, not just as a coder, but as a collaborator and owner.
Yeah, this is crucial. The best engineers influence beyond just the code. Let's talk ambiguity. Product specs or designs come in, and they're unclear. How do you effectively partner to get things moving?
You have to short-circuit the debate cycle. Don't get stuck arguing about hypotheticals. The best strategy is usually to build something tangible fast. A clickable prototype using Figma, or even just a thin vertical slice of the actual feature may be built in just a day.
Get something real in people's hands.
Exactly. That forces concrete feedback. And crucially, agree on the success metrics up front. What does done actually look like? Then iterate based on that rapid feedback and analytics, not just opinions.
What about that common blocker? The backend API isn't ready or the spec is still changing. How does the mobile team keep making progress?
The mobile team really needs to drive the contract definition here. Don't just wait. Propose an API schema, maybe using OpenAPI Swagger. Get agreement from the backend team on the basic request and response shapes.
Define the interface.
Right. Then generate your client-side models based on that agreed schema. Develop against a mock server or even just local stubbed data. And wrap the actual network calls behind an adapter layer. That way, when the real API comes online or changes slightly, you only have to update the adapter, not your entire feature logic. It keeps you unblocked.
Smart. Okay, the ultimate test of ownership and process. A critical crash pops up right after a release. High pressure situation. Walk us through the response plan.
Yeah, okay, deep breath. It's a rapid sequence. Step 1, verify. Check your crash reporting dashboard, Crashlytics, Sentry, whatever, immediately. Confirm the impact. Can you reproduce it? How widespread is it?
Step 2, damage control.
Exactly. Pause the phased rollout if you're doing one. If the impact is severe, initiate a full rollback to the previous stable version. Stop the bleeding first.
Okay, stop the bleeding. Now fix it.
Step 3, hotfix.
Yeah.
Create a dedicated hotfix branch from the release tag. Find the root cause, write the fix, and crucially add a targeted test case to prevent this specific crash from ever happening again. Get that fix reviewed via an expedited process.
And step 4.
Communication. Constant updates. Keep stakeholders informed via Slack or status pages. Give customer support a workaround if one exists. And after the immediate crisis is resolved, write up a thorough root cause analysis document. Learn from it.
Clear steps. Finally, let's touch on challenging collaboration. The sources mentioned an example. Disagreeing with a design proposal for a complex gesture that was maybe cool but risks the timeline. How do you navigate that constructively?
The key is shifting from opinion to evidence. In that example, the resolution wasn't just arguing. The engineering team proposed building quick A/B prototypes of the complex gesture versus a simpler alternative. Then they ran usability tests.
Let the data decide.
Pretty much. They agreed on shipping the simpler, safer default interaction to meet the deadline, but maybe hid the more advanced gesture behind a long press or a setting. It met the timeline, respected the design intent to some degree, and actually the simpler version performed better in the user tests anyway. Win-win, driven by data.
That's a great example. So pulling it all together, what we've seen across these sources is that a truly effective iOS developer needs excellence in like 3 key areas. There's the deep technical mastery, memory, concurrency, the fundamentals.
Then there's the robust system strategy, thinking about performance, CI/CD, persistence, architecture choices.
Right. And finally, that cross-functional leadership piece, handling ambiguity, managing crises, collaborating effectively.
But digging through all this, what the sources really force you to confront is where you draw the line, those trade-offs. What's truly non-negotiable, even when you're under immense pressure to ship fast.
That leads to a really interesting final thought for you, the listener. Consider this non-negotiable question. When, if ever, is it acceptable to defer accessibility or localization work in, say, a startup MVP just to hit a critical deadline?
It's a tough one. But the strategic answer, if you're aiming for true quality, seems to be this. You must always maintain foundational accessibility. That means support for dynamic type resizing, sufficient color contrast, basic voiceover labels on interactive elements, and adequate tap target sizes.
Those are table stakes.
Right. You might defer full localization translating into multiple languages, but only if you've properly externalized all your user-facing strings from the start and you have a concrete plan and deadline in the backlog to actually do the translation work soon.
So some things can be deferred, but the foundation must be solid.
Exactly. That level of judgment, knowing the absolute non-negotiables versus the things you can strategically defer. That's really the difference between just being an informed developer and being a truly strategic one. Something for you to mull on.